Hello geometry students, welcome back to another video lesson today in geometry where we are going to apply properties of kites. We're going to be looking at the unique properties of our kites, the quadrilateral that we have learned a little bit about in the last couple of days. So there are some unique properties that exist in and only a kite. You might want to make sure that you get these written down. So a recall by definition that a kite has two distinct pairs of consecutive sides that are the same length. Okay? Two distinct pairs of consecutive sides that are the exact same length. So in this one, we've got these two sides congruent, these two sides congruent. Now, if I were to create a couple of different triangles, and it's not going to be exact because of the way that I made it, but if I were to create a triangle here, and we just focused on the triangle on the left, this is an isosceles triangle, and we just learned that if the two sides are congruent, then those angles are going to have to be congruent. Similarly, if I look at the right-hand side, this right-hand triangle is also an isosceles, meaning that angle, we'll put 2 marks on it, has to be congruent to that angle. So if we drop this, what's called an altitude, it actually helps us to create some isosceles triangles, which helps us to also find missing angle measures if we're given one of those. All right, now the other part, and I'm going to just delete all of that for a second. What happens if I were to draw a triangle the other way and connect it maybe this long way? Well, notice, and this isn't a very exact one. There we go. Notice that the top triangle and the bottom triangle are going to be congruent. One side to one side, this side is they would have that symmetry. Okay, and because they have a symmetry, we also know that this angle here is going to have to be congruent to that angle, which we kind of just proved. All right, the other part of it then, if I have that longer altitude and I drop that second altitude in there, these two lines are going to intersect. Ooh, that was really bad. Those two lines are going to definitely intersect at a 90-degree angle. Okay, so that's a 90. We just said this is congruent to that. And we said before that this one is congruent to this one. All right, now we're going to look at some special properties that exist, okay, because of that. Number 1, all right, DB, that longer one that we drew, okay, you might want to write this kite down with those letters. This line, DB or line M, is a line of symmetry. Right? I could fold it in half, rotate all the way around, reflect all the way around. So it's a symmetry line. All right? And because it's a symmetry line, if I drop in this perpendicular bisector, it means that it cuts it into 2 equal parts. So that segment will have to be equal to that segment. A to the midpoint is the same as the midpoint to C. We also said, again, this angle is congruent to that angle, this angle to that angle. So a lot of different things happening here. But it's important to note that they do intersect at a perpendicular bisector, meaning all 4 angles are 90, and this line is cut in half. Angle C is also congruent to angle A. A lot of different things happening in this diagram, and it's all more so than about how do we apply them. Okay, so I would make sure you have that kind of information written down so that you fully understand what's happening. So let's look at an example. If we are given kite, K-I-T-E, that this is a kite, all right, or they're telling us, given a kite. So I know that this side has to be congruent to that side. I know that this side has to be congruent to this side. And it ends with KT. It's important. That's the ending, meaning that's the longer line of symmetry. If EM is 8 and the measure of EKT up here is 4D, and ITK is 23.5. Find as many other lengths and angles as you can. That's a lot of stuff to try and figure out. A lot of different stuff. Well, one of the things, if we know that this line up here, E to M is 8, what else do we know is 8? We also know that IM, segment IM, is 8. That was a perpendicular bisector, so this line would have to be 8. What do we know about all of the angles here around M? They all have to be 90. Right? And we typically only draw it on one, because if that's 90, that's 90. If that's 90, so is that, and so on. So we typically just draw it on one. All right? So we know all of those around M. So if we know those are 90, and I'll just put it here again, can we then figure out this angle up here? Angle KEM would equal 50. It's going to equal 50. How do I know it's 50? Well, every triangle has to have 180. So that's going to be 50. All right. Again, if I cut this triangle off, if we know the angle here in the triangle is 50, and the two sides are congruent, we also know down here is 50. And since this is 90 and 50, we also know that up here at K would have to be 40. If this one's 23.5 and this is 90, right, we can then find MIT, angle MIT, 180 minus 90 minus 23.5 would be 66.5. So we know that this angle right there is 66.5. Because we know that one, again, if we took this bottom triangle off, just draw it down here for a second to illustrate. There's my bottom triangle. And we said this angle in the bottom was 66.5. It's right there. What do we know about this other angle up here? Or this one, TEM? Angle TEM is the same. 66.5. So that would be this one. And if this is 66.5 and this is 90, what do we know about this angle? Well, it has to be 23.5 because we already did that math on the other side. So notice, just by having a couple of angle measures in this kite, we are able to find all of the other angle measures and thus kind of going through the isosceles triangle properties of it-bat and sit-bat to help us. Let's take a look at one more. All right, here's a rhombus. Okay, rhombus, four sides being equal. But remember, a rhombus is a special type of kite. Okay, it is a kite. All right, and then here's what happens in a rhombus. These two are congruent to each other. These two short segments are congruent to each other. All four of the outside are congruent. They tell me that the measure of RED, so R to E to D, this angle right here is 52. Are we able to find these four? All right, those four. What is R to E to P? R to E to P. Well, notice. This is a symmetry line. This rhombus has a symmetry line from R to E. It also has a symmetry line from P to D. So if I were to reflect everything across, what would this angle have to measure? The exact same because of that reflection. So 52. What about Dr. Dre? I mean measure Dre, D-R-E, D to R to E. What about this one down here? Well, notice, once again, if I peel off this top and say that side's congruent to that side, and this was 52, this bottom angle would also have to be 52. So we got another 52 degrees. right. What about e to r to p? E to r to p. So now we're looking at this one. Well, once again, if that was 52, so does this one. Or if that one is 50, so we got another 52 degrees. What about ODE? O to D to E. Now we're looking for this one up here. Well, now we get to the triangle sum. 180, take away 90, take away 52. Where did that 90 come from? Well, remember, these intersect perpendicularly at a 90-degree angle. So if we're left with 180 minus 90 minus 52, we would have 38 degrees for this ODE. So again, a kite has some unique properties based on what it's set up as and where they give us certain angle measures. If you have questions as you're working through today's problems, especially how to set it up or what angles are congruent, please make sure that you reach out. Otherwise, until next time, folks, stay safe.